Hello everyone, thanks for watching this video. So in this video, today we are going to understand how to delete the node or how to delete the element from a singly linked list at a given position. Okay, so basically we will be getting one singly linked list, something like that. Okay, and our responsibility is to delete the element or delete the node from the index that we are receiving from the user. Here if you see, this is our singly linked list that we are receiving from the user, and our responsibility is to remove the element from the fourth index. So if you see 1 2 3 fourth index, we have element as a 40. So we have to remove this element and we have to build one output something like that: 10 20 30 40, no 40 we are deleting, right? So 10 20 30 50 60. Okay, so basically we are deleting this 40 and we are just getting 30 50 60, 30 50 60, 10 20 30 50 60, right? Good. So in order to delete the element from the given position of a singly linked list, so we have to perform some set of tasks, or we have to follow some set of algorithm. So first algorithm is, as always, we have to create the singly linked list. Okay, after creating the singly linked list, we have to load the data. Okay, after loading the data, make a connection. Okay, and after making a connection, just to make sure that everything happened correct, so we have to display the singly linked list. Okay, after displaying the singly linked list, we have to delete the node or element from the given index. Okay, once we delete, then our again next task is to display the singly linked list, just to make sure that the element what we have deleted, that got deleted successfully. Okay, so as per first part means creating the singly linked list, and we know how to create. So how we are going to create? We will be having one inner class. Okay, so private static class list node. Okay, so here we are going to define two variables. Okay, one is private int, since I am going to create the singly linked list as an integer type, so int data. Okay, and second one is the reference of the next node. Okay, which we are calling as a next. Good. So after initializing, after creating these two variable, which is private type, our responsibility is to initialize also, and for that we are going to use a constructor. Okay, and in the constructor we are going to pass data as a argument. Okay, good. So this dot data equal to data, and this dot next equal to null, since by default the reference of the next node is null. Good. So we created the class and we defined or we declared two variables. First one is the data and second one is the reference of the next node, and we initialize these two variables using constructor. And while initializing, I am just making the reference of the next node is by default null until unless we have to make the connection. So basically we are done with the first task. After first task, these are all tasks related to client side. Okay, so that's the reason we are going to perform. These are all tasks in main method. Okay, so here we will be having one main method and we are going to perform the remaining task. So second task is to load the data. Load the data means create the constructor and pass the data. So first equal to new list node. Okay, here I am going to pass data as a 10 since our input is something like that, 10 to 60. Okay, so this will be a 10. So this one is 20, 30, 40, 50. Okay, one more 60. Okay, good. So we loaded the data. So this is the first node, and first node is also called as a head. So we can say this one is the head, and this one is the second node, and this one is the third node, and this one is fourth node, and this one is fifth node, and this one is sixth node. So we created total 6 nodes and we loaded the data. After creating the node, we have to make the connection. Connection means first node means head I am going to attach with second node using the next. Next means reference of the next node. So first node means head I am going to attach with the second node, and second dot next I am going to attach with the third node, and third dot next I am going to attach with fourth node, and fourth dot next I am going to attach with fifth node, and fifth dot next I am going to attach with sixth node. So all the nodes got interconnected, so which is good. After doing the connection of node, we have to write a logic to display the singly linked list to make sure that we created and we loaded the data correctly. So for that we are going to write one display method. Okay, and inside that we are passing head as a argument. Okay, so we are going to create. Good. Right, so we received the head from the user. So after receiving, we have to secure the output, secure the input data. So we will be having one local variable called current, and we are going to traverse from one node to another node till last node in order to display the element. So that we are going to perform through while loop. And we have to traverse from first node to last node, and for last node we already know the reference of the last node is null. So that's the reason I am checking here. I have to travel only not null. Once I reach the null, then I have to come out of this loop. So we will understand, okay, we reach the last node. Good. That's why we are checking current does not equal to null, means I don't want to reach the null. Null means last element. Okay, so we are going to print the data. So data means current dot data. So here I am going to print the data for first element. Okay, and I am going to have one separator. So this will be going to make me understand this is the first node and this is the second node. And I want all the data to be printed into the same line, so no new line required. Okay, so this I have printed for the one data. Now I have to move from one node to another node, right? So to do the movement, we are going to say current equal to current dot next. This code will help you to move from one node to another node. So we are good. As soon as I am coming out of while loop means we met the null. So it's our also responsibility to print the reference of the last null to make sure that okay we really met. Now if you right click and run a Java application, we will be getting the data as we loaded 10, 20, 30, 40, 50, 60. Means whatever data we have loaded that we are able to print correctly, which is good. Okay. Now our main responsibility start from here. What is the main responsibility? We done with the display, means fourth task we are done. Now our fifth task is to, this is the actual requirement, means to delete the node or element from a given singly linked list. So for that we are going to write one method called delete, okay, at given index. Okay, so we are going to pass index as a 4. As per this program we are passing index as a 4. We can take anything. Okay, that is good. So we are going to create one value called int index equal to 4. Okay, and here we are going to pass index as a argument. This is the first argument. Okay, and the second argument, so first argument is the linked list. Okay, good. So we pass the two argument. First argument is the linked list from where we are going to delete, and the second index is the index, means from where we are going to delete, right? So accordingly we are going to create the method. So we created method here, and we receive the two data from the user. First data is the linked list, and the second data is the index from where we need to delete the singly linked list. Okay, good. So we are going to create one local variable to secure the data that we are receiving from the user. So this is the linked list. So we can create one local variable called previous. Okay, just for our understanding. Okay, and the position means index from where we are going to delete the data. So we are good till now. Okay, good. Now question is that if you right click run as Java application, so this is our basic linked list. Okay, and from here we are going to delete the data from the index 4. If you see here, index 4 means from 4th position we are going to delete the data, means we are going to delete the data 40. Okay, you have to remember one thing. Okay, in order to delete, if you want to delete the any node, any data from the singly linked list, okay, or in the singly linked list, then you always have to remember that you should not directly jump to 40. I mean, for which you are going to delete. Okay, for me I want to delete the 40, so I should not directly target the 40. I should go 30 only, just before one node. I will tell you why. The reason is, if you want to delete the 40 means that you just have to assign the null first. Second thing is that you just have to make a connection from 30 to 50. Okay, so here 40 shouldn't play any role for you. Okay, it's just that we want to delete, so we should not directly target the 40. It's not say array. Okay, we directly hit the index only. No, to delete any of the element from singly linked list, we have to hit the just before one index element. If you want to delete the 5th index, so you have to directly, if you want to delete the 5th index, means you have to directly go to the 4th index. You should not directly go to the 5th index. If you want to delete the element from the 6th index, means you have to target the 5th index, then only you can able to delete the 6th index. So this is the logic you have to follow, then you can easily you are get to know. Okay, now we want to delete the 40. Okay, in order to delete the 40, I have to target the one index before, means 30. So what I will do is 30 I will make a connection with the 50. Okay, so automatically this 40 got deleted. That's the reason I just target one index before. Okay, so for that we already know with the help of while loop we can traverse from one node to another node. Okay, good. Now question is how to traverse. So traverse logic is same, previous equal to previous dot next. This will help you to traverse from one node to another node. Now my question is how I will make sure that I will be reaching 30 or I will be reaching 40, 50, any of the elements. See, this index is telling us to delete the data from here. Okay, so as I already told you, if this index is telling me to delete the data from 40, so I should go till 30, means -1. Okay, now question is how I will go. So for that we will be having one counter variable equal to 1. Okay, good. And now I am with the help of this counter variable I am just traversing from one node to another node. Okay, good. Now question is that you have to tell me what is the value of previous dot next dot data. Okay, if you run here, if you keep one SOP here, previous dot data means previous dot next is already got assigned here. Okay, now if you run this program as a Java application, you will see something else. You will be seeing 20 and 30. 10 is part of this one. Okay, don't confuse. But we haven't seen the 10. Okay, we know that we are traversing from first node to last node or middle node anywhere. But here while traversing, we got to know that we don't have the data as a 10. The reason is I got the linked list. Okay, and I have created the local variable here. So as soon as linked list come, okay, this is the first node, right? So from first node I just start traversing. Okay, so if you print the previous dot data, means there is no point that I will be traversing from one node to, means head to head only. I should be traversing from head to second node to third node. There is no point that I should be traversing from head to head. That's the reason you are already losing your first data here. We are not losing, actually our data is already there. So if you print here previous dot data, right click, run as Java application, you will be getting 10, 20, 30, means this is your 10 data is already there. Okay, we are traversing from 10 to 20. That's why previous equal to previous dot next, and we are printing it here data, right? Good. So my question is, we are coming out of this loop, right? So as soon as I am coming, see 10, 20, 30. 30 is already in my hand, right? So to delete the 40, I should always have to target the 30, and 30 we received here. Means latest element, means last value of this previous dot data is 30, right? Good. Now our next task is to secure the 30 somewhere. Okay, now question is how to secure. So we will be creating one temporary variable current equal to previous dot next. Okay, so if you print it here, now this code is done. Now if you print it here current dot data previous dot data, good, this will give you the, okay, I will explain you how. One SOP here, I want to print three things here, 1, 2, 3. Okay, Now previous dot data, you have to tell me what is the value. I want to print the current dot data also, okay, and I want to print current dot next dot data also. Three things I want to print it, okay. Now you have to tell me what is the value here for first SOP. What is the value? So see, previous dot data means I am just getting the data from here only. I am not printing the previous dot next dot data. I am just printing the previous dot data, means what is the value available, last value of previous inside the while loop. That's only I am going to print it here. So this will give you the 30. Okay, good. Now as soon as I am coming out of while loop, what I am doing is previous dot next. Previous already have 30. Now I am moving one step ahead, means previous dot next means 40, and 40 I am assigning to current, that I am printing it here. So this will give you the 40, right? Good. Now what I am doing is I am just doing the one movement from current node, current dot next, and I am printing the data. So one movement means 40 to 50. So we got 30, 40, 50 outside of the while loop, where inside we already have 20, 20, 30. Good. We don't have anything for 60 now. Okay. Right click, run as Java application. If you see 30, 40, 50. 30, 40, 50. So we are good now. Anyhow, we haven't performed any operation. We are just printing the data. Okay. Now we have to set the logic. Logic is very simple. We have to delete the 40. In order to delete the 40, I just have to concentrate on 30, 50 and 60. 30, 50 and 60. Right? 30, 50 and 60. We don't have to concentrate on 40. First task. Second task is we also don't have to concentrate on 60. Means 60 is already attached with 50. So if we will concentrate 50, 60 is automatically got concentrated. Okay. Now we have the 30 and 50, two elements are into the picture in order to delete the 40. Okay. So what we will do is 30 got connected with 40, right, and then 40 got connected with 50. What I will do is 30 I will connect directly to 50, and 50 is already connected with 60, so no work has to be done here. Only what I will do, 30 I will connect with 50, so automatically 40 got out of the scope and it got deleted, right? So our all value is here, 30, 40, 50 is there. So we have to main concentrate on 30 and 50, means this is your 30 and this is your 50, right? So how we will concentrate? So previous dot next equal to current dot next. Okay. Now what is the previous dot next? Now what is the previous dot next? Means your 40. Okay. Now I will tell you one more thing here. You do one thing. You just comment this one, copy this one, paste it here. Okay. Now we understand there. Now we have to print the previous dot next dot data. Previous dot next dot data and current dot next dot we already have here. No problem. You deleted this one. Okay. So what we are doing, previous dot next dot data, current dot next dot data. We don't know what with the value here. You have to guess it. Tell me what is the value here. Here and here. Now if you run, right click, run as Java application, you will see 50 and 50, right? Previous dot next will give you the previous dot next is giving you the 50, and current dot next is also giving you the 50. That's the reason Reason because I am assigning it here. Okay, so if you comment this x and print it here, okay, since I am just assigning it here, so that's the value got overlapped. Print it here, see 40 and 50. Okay, so what I am doing here is, first this guy is having 40 and this guy is having 50. I want to delete the 40. So 40 means current dot next, sorry, previous dot next. I am just assigning 50 here, means overlapping the 40 and assigning the 50. Okay, overlapping the 40 with 50. Okay, now 50 is already there, so we have to assign this one as a null. Okay, if you won't assign also, it won't give you the any problem. Only thing is that in memory the data is already occupied for this one. Okay, I will tell you why. Okay, if you comment this code here, okay, reason is this is the delete. After delete we haven't have the display method. All right, so let's have one display method also. No logic changes, same display, then we can able to understand the changes. Okay, come here, you see 10, 20, 30, 40 got deleted, 50, 60, right? Now question, we understood this line very correctly, we commented this one. If you uncomment this one also, you see you won't get any problem in your output. Same 10, 20, 30, 50, 60. Only thing is that in memory for this data is value is address already there, so I want to release the memory from the memory. Okay, that's the reason I make as a null. If you want you can give, if you don't want you cannot give, but only thing that we have to make a constant on memory things. Okay, so we are good now. We have to delete this all SOP what we don't need. Okay, now we don't need this SOP also, we don't need this SOP also, we don't need this SOP also. Okay, good. Let me, okay, good. Now so we are able to delete, which is our expected output. Okay, another thing what you can do is, in deleting, right, you always have chance to release the memory. So for that you can use one inbuilt garbage collector. Okay, so you can use the GC from the system class. That is also good practice to use. Okay, so let me run again, run as Java application. You see 10, 20, 30, 50. So let's have one SOP here called before deleting the node. Okay, and you can say here after deleting the node. After deleting the node, this will give you some meaningful message here. Before deleting this one, after deleting this one. Okay, good. So let me summarize you again. So our task is to delete the node from the 4th index. So in order to delete the node from the 4th index, first thing is that we have to create the singly linked list. After creating the singly linked list, we have to load the data, and we did something like that. After loading the data, we have to make the connection. Once connection done, we have to display the singly linked list, make sure that we loaded the data correctly, and we have made the connection also correctly between one node to another node. Now our next task is to delete the node from the given index. Given index is 4, that we are receiving from the user. So logic is to delete the node. So if you want to delete the node 40, so we have to go till 50, we have to go till 30. Okay, and 30 we have to connect with the 50. So that's what we did is, we received the linked list, we received the position from where we are going to delete, and we traverse through this while loop and have one counter. With the help of counter, what I did, I traveled from 10 to 30, not 40, 10 to 30. So after coming out of this loop, so previous dot data got 30 and this current got 40. Okay, so I am just overlapping the value from here with this code, and after doing the overlap this value, so this current dot next I am just making as a null. Just only thing is that it won't give you any problem in your output, but we have to release the memory that we already occupied. So that's the reason we made this as a null. Otherwise no logical changes it here, and we are able to get the expected output, and we are able to delete the 40. If you pass here 5, okay, so we should be also be able to get the 50 element got deleted. See, 10, 20, 30, 40, 50 got deleted, right? Now question is, if you pass it here 10, what will happen? You will get the null pointer exception. The reason is our linked list size is 6 only, and you are deleting the element from the 10th position. Obviously it won't make any sense, though it should give you the null pointer exception. So this is your task to have some small validation. Just the index value is less than or equal to your length of your singly linked list. That probably you have to do yourself. Okay, I have already created one program to get the length of the singly linked list. So having this logic, you have to make a small validation here. Okay, so we are good now, and we got the expected output also here. Okay, yes, thanks for watching this video.